No one knew how the tower was still standing. The tower would topple if it reached an angle of 5.44 degrees, and it was currently leaning at 5.5. In 1990, the Italian government enlisted top engineers to stabilize Pisa's famous Leaning Tower. There'd been many attempts to right the tower during its 800-year history, but this team's computer models revealed the urgency of their situation. They projected the tower would topple if it reached an angle of 5.44 degrees, and it was currently leaning at 5.5. No one knew how the tower was still standing, but the crisis was clear. They had to solve a problem that stumped centuries of engineers, and they needed to do it fast. To understand their situation, it's helpful to understand why the tower tilted in the first place. In the 12th century, the wealthy maritime republic of Pisa set about turning its cathedral square into a magnificent landmark. Workers embellished and enlarged the existing church and added a massive domed baptistry to the plaza. In 1173, construction began on a freestanding campanile, or bell tower. The engineers and architects of the time were masters of their craft, but for all their engineering knowledge, they knew far less about the ground they stood on. Pisa's name comes from a Greek word for marshy land, which perfectly describes the clay, mud, and wet sand below the city's surface. Ancient Romans counteracted similar conditions with massive stone pillars called piles, which rest on Earth's stable bedrock. However, the tower's architects believed a 3-meter foundation would suffice for their relatively short structure. Unfortunately for them, less than 5 years later, the tower's southern side was already underground. Such a shifting foundation would normally have been a fatal flaw. If workers added more weight, the pressure from upper stories would sink the structure and fatally increase the lean. But construction halted at the 4th story for nearly a century as Pisa descended into prolonged warfare. This long pause allowed the soil to settle, and when construction began again in 1272, the foundation was on slightly more stable footing. Under the direction of architect Giovanni di Simone, workers compensated for the tower's minor tilt by making the next few floors taller on the southern side. But the weight of the extra masonry made that side sink even deeper. By the time they completed the 7th floor and bell chamber, the angle of the tilt was 1.6 degrees. For centuries, engineers tried numerous strategies to address the lean. In 1838, they dug a walkway around the base to examine the sunken foundation, but removing the supporting sand only worsened the tilt. In 1935, the Italian Corps of Engineers injected mortar to strengthen the base. However, the mortar wasn't evenly distributed throughout the foundation, resulting in another sudden drop. All these failed attempts, along with the ever-sinking foundation, moved the tower closer to its tipping point. And without definitive knowledge of the soil composition, engineers couldn't pinpoint the tower's fatal angle or devise a way to stop its fall. In the years following World War II, researchers developed tests to identify those missing variables. And in the 1970s, engineers calculated the curved tower's center of gravity. With this data and new computing technology, engineers could model how stiff the soil was, the tower's trajectory, and the exact amount of excavation needed for the tower to remain standing. In 1992, the team drilled diagonal tunnels to remove 38 cubic meters of soil from under the tower's north end. Then, they temporarily counterbalanced the structure with 600 tons of lead ingots before anchoring the base with steel cables. More than 6 centuries after its construction, the tower was finally straightened to a tilt of about 4 degrees. No one wanted the tower to fall, but they also didn't want to lose the landmark's most famous feature. Today, the tower stands at 55 or 56 meters tall, and it should remain stable for at least 300 years as a monument to the beauty of imperfection.